Hey everyone, welcome back to the channel. Problem number 33, search in rotated sorted array. So this problem is about finding an element called target in an array called nums that was originally sorted in ascending order but has been rotated at unknown point. For example, it's something that we need to understand how this will work. For example, we have this one. This array might have been rotated to, for example, um, disk like that. It might be rotated to this, like instead of 1 2 3 0 1 2 3 4 5 6 4 5 7, it will 0 1 2 4 5 7. So it's been rotated 3 times. The goal is to find the index of the target value if it exists, or return -1 if it does not. Okay, so there are key points that we should put in our head. First of all, the array is initially sorted but has been rotated, meaning it is no longer in perfect ascending order throughout. Okay. Second, you need to solve this problem with a time complexity of O of log of n. Okay, this is something also you will see, like we need to solve it on O log of n, which strongly suggests using a binary search approach. So let's try to think how the algorithm will work. So we use a modified binary search to find the target. The key is to identify which half of the array is sorted during each step of the binary search. And let's try to think about how we will do this one. First, we could think about the binary search concept. So a binary search is a technique used to find an element in a sorted array by dividing, like, let's say that if I have an array of let's say that let's take an example, the old example that I had. Let's go. Yeah, let's say that I have. Oh, delete all of that. Let's say we have this array. So basically, the binary search, it will be, we'll divide the array by 2, and we'll try to divide it by 2 until we find um, our own our own element. So we use basically it's a technique to use to find an element in a sorted array by dividing the search space in half repeatedly, which leads to a time complexity of O of log of n, O log n. Okay. So since the array is rotated, it might be divided into two parts, one of which is always sorted during each iteration. We should determine if the left half or the right half of the current segment is sorted by comparing the values at left and mid, and by this one it will be we could find it in this way. So let's try to think about how we can do it. So first, let's just start um with 2 pointers. So let left, which will equals 0, and let right, which will equals nums dot length -1. I could create a while loop here. So while left is less than or equal right, and yeah, let's start. So first we will have ment, and in any binary search, let's go here. So in any binary search array, if we have like an array that has 1 and 2 3 4 5, and for example we're searching for 3, or let's say searching for 2, what we will do, let's assume that we're searching for 2. In binary search, we will divide our our array into two half, so we have like 3, 4, 5, and 1, 2, and we will take the mid inside both of them, and the mid will be 3, and we will see if 3 is equal to the number or not, but 3 doesn't equal to 2, so 3 is bigger. So since 3 is bigger, that means, and since this is a sorted array, that means all the other number on the right will not equals to 2 at all, or not, will not be equal to a target. So we'll have 1 and 2, and when we start to split them and try to find the mid, and by this one I guess the mid will be 2, and we find 2 equals 2, so we will have our own array. So this is how binary search works. So we will create a while loop, and we will get mid, and mid will equals math the floor be left plus right divided by 2. Okay. And we need to check if the middle element is a target. If nums of mid equals target, if that was the case, we should return mid, which is the index. Okay. If that wasn't the case, we need to determine which side is sorted. So I would say first I'm gonna create an if statement. If nums of left is less than or equals nums, oh no, is less than or equals nums of right. If that was the case, that means the array is sorted. So I would say if target is bigger than or equal nums of left, if that was the case, and target should be as well smaller than nums of mid, if that was the case, we should we would try to see the left side. If that was the case, target is on the left side. So when we say target is on the left side, that means the right will equals mid minus 1. And I'll take else, it will be, that means target on the right side. So left will equals mid plus 1. However, if the array is not sorted, this is if the array is sorted. If the array is not sorted, we will do it that way. So else, the right side is, we will try to find if here we determine if the left side is sorted. Okay. First we sorry. We determine which side is sorted. Okay, and if that was the case, the left side is sorted, and else that means the right side is sorted. And while we're saying that, we will say if target is bigger than nums of mid and target is less than or equals nums of right. If that was the case, I would say left, that means target is in the right sorted portion, so left will equals mid plus 1, and else that means the target is in the left portion, so it will be right equals mid minus 1, and in the end I will return minus 1 because we don't find anything. Let's try to run and see it work or not. It didn't work at all. Target 0 expected. It didn't work as we wanted. Okay, there is something wrong I have done here. Let me try to understand what's going on here. Okay, let's see. So while left is big than or equals right, smaller than equals mid. Okay, so if nums of left is smaller than or equals nums of right. No, 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 no. If nums of left is smaller than, it should be mid. Yeah, okay. If nums of left is smaller than or equal nums of mid, and we have here, we will try to do the left. That means we try to see if the left side is sorted. So target is bigger than or equal, and here, yes, return mid, run, submit. Okay, it did work. Okay, so let's try to look in this problem in details, because it's not easy problem to understand. Specifically, this section is pretty confusing. So okay, so we start with 2 pointers, left and right. Okay, we have one left and right. The beginning, left at the beginning, which is 0, and right at the end, which is nums.length minus 1. After that, we need to we just to see if we find the middle, we return it anyway. We have here, we calculated the mid. So calculate the middle index, which is using left plus right divided by 2. And after that, we need to check if the middle element, which is nums of mid, is equal to the target. If it is actually equal to the target, if let me just, okay, so if where we are, yeah, we need to check if the middle element, which is nums of mid, is equal to the target. If it's equal to the target, mid has the index where the target is found, and it is returned. After that, we need to determine which side is sorted. So if nums of left smaller than or equals nums of mid, it means the left side is sorted. If the target lies within the range from nums of left to nums of right, then move to the right pointer. Okay, again, again. If the target lies within the range of nums of left to nums of mid, because this is the if statement. So yeah, where we are, yeah, we then we move to the right pointer to mid minus 1 to focus on the left side. Otherwise, move the left pointer to mid plus 1 to focus on the right side. If mid smaller than nums left, it means the right side is sorted. If the target lies within the range from nums mid to nums right, then move the left pointer to mid plus 1 to focus on the right side. Otherwise, move the right pointer to mid minus 1 to focus on the left side. Repeat this process until left pointer exceeded the right pointer, which means the target is not in that array. We return -1 if we can't find it. Let's just try to make an example, a walkthrough example, so we understand everything. So let's assume we have an input and this array is nums, and I guess this one is rotated 3 times. So first, at first iteration, mid will equals, I guess mid will equals 3, and so that means the value will equals 7, because it's an index 3. Since the target side, since the right side is 0, 1, 2, is sorted, and the target 0 lies within this range, we move the left pointer to 4. So basically that means we will be at 0. Okay, we move the left pointer to 4. Second iteration, mid should be second iteration, mid should be is 5, value at 1, because we moved it at 4. So basically we do not care about all of that. So right now we have 4, so the mid should be 1. So again, the mid is 5 and the value is 1. Now the left side is 0, which is 0 is sorted, and since the target is 0, move the right pointer to 4. Okay, the third iteration, mid will equals 4, which have the value of 0, which matches the target, and we return 4. So we can do this with, I highly recommend you to do with in your head with this example. When there is no 3, so we return -1. But we will try everything. So the algorithm effectively finds target by repeated determining which half of the current array segment is sorted, and adjust the search range accordingly, basically. So the time complexity is O of log n, which is optimal for searching in rotated sorted array. So that's it for this video, and see you in the future.